So, the first exercise is asking you to get the force between two positive charges, both with a charge of 3 times 10 to the minus 6, separated by a distance of 0.1 meter, and tell if they are rejecting or attracting each other. First of all, we know that both charges are positive, so they are pushing each other out, so they are rejecting. Then, to get the force between them, you just have to use this formula, to get a force of 0.808 newtons. The third exercise is asking you to get the electric field of a charge inside an electric field with a force of 8.10 to the minus 4. This one's really easy. All you have to do is use this formula to get an electric field of minus 200 newtons over coulomb. The fourth exercise is asking you to get the electric field that makes an electron stop at a distance of 0.028 meters if the electron was going at a speed of 3.75 times 10 to the 6 meters per second, and also to get the time it took to stop inside the electric field. So we know that it is moving horizontally, so if both the velocity and the distance are positive, you can tell that the electron is moving to the right. Then, to get the electric field, you just have to use this formula, using the charge of the electron, which is minus 1.6 to the minus 19 coulombs, to get an electric field of 1.83 times 10 to the minus 6 newtons over coulomb. Finally, for the time, you just use this formula and clear out for time, since we already know the distance and the velocity, giving us a total time of 7.46 times 10 to the minus 9 seconds. The fifth exercise is asking you to describe a formula to express the electric field of a charge of a solid sphere from the center of the sphere. There is a formula in Gauss's laws that describes this type of electric field, which is this one. The radius to the square is to represent the distance at the center of the sphere. The fifth exercise is asking you to get the number of excess electrons that have to be added to a sphere to get an electric field of 1030 newtons over coulomb, and to get the electric field of the sphere if it is 10 centimeters apart from the center. Knowing the charge of the electron, we can just use the rule of 3 to get the number of excess electrons to get the desired electric field. But first, we have to know the charge of said electrons. So we use this formula and clear out for Q to get the charge of 1.9 times 10 to the minus 9 coulombs. And now we use the rule of 3 to get the numbers of excess electrons that we need, being minus 1.2 times 10 to the 10 excess electrons. Finally, to get the electric field of the sphere when the field is at 10 centimeters apart from the center, we use this formula to get an electric field of 1740 newtons over coulomb. The seventh exercise is asking you to get the work of an electric field of 5 times 10 to the 4 when a charge of 5 times 10 to the minus 6 located in a negative plate moves to a positive plate that is 0.05 meters above the negative plate. As this exercise is asking you to get the work, we just have to use the work formula according to an electric field, which is this one, to get a work of minus 0.0125 joules.